Okay, we're going to populate it. A back sight is looking at something that I know. So back sight on 257.61 is 4.72. So that goes right here. Okay? Now, I don't know the elevation of the next two, but look at what happens. Do I ever look back at these green rods? When I set up here, do I ever take an LL shot at these green rods? No. So if I don't know the elevation and I'm never going to look back on it again, it's called an intermediate foresight or a side shot. So 0, 0, intermediate foresight. 50, intermediate foresight. Now I'm taking a foresight on TP1. TP1 foresight. Now hopefully that makes sense to you. I'm sitting here. I look back on benchmark. Back sight. So back sight on BM61. That's why the 4.72 went there. I look here and here. They're on green rods that I never look back at. They're a foresight because I don't know the elevation, but I don't need to look back on them, so they're an intermediate foresight. So they go there and there. Then I see TP1 and it's a foresight. So these are how do I know it's a foresight? Look what happens when I move my gun. Don't I look back on that red rod? So there's a sight coming in and a sight going out. That's a foresight or back sight and a foresight. So foresight coming in, going back is a back sight. So there's my foresight. So 2.01. Move my gun up the hill. First shot I take is a back sight on TP1. Then I take 3 intermediates. That's the 3 green rods. Then I finish it off by taking a foresight on TP2. Hopefully that population makes sense. This is the hardest part, is figuring out where to put the numbers. Okay? Hopefully that makes sense to you. Now what do? To get my height of my eyes, I take 257.61 and I add 4.72 to it. Okay, when I do that, I get 262.33. This plus that equals that. Okay, now notice this is my eyes right here. Does it make sense that I can take all 3 of those numbers and subtract from 262 to get elevation of here, here, and here? So if they're intermediate foresights, all I do is this. Hopefully you can see that. Okay, if I do that, then I'm going to get elevations of all of those guys. And if I do that, I get 257.91. I get 258.03. And I get 260.32. Okay, now I've got an elevation right here, 260.32. Does it make sense if I add 511 to it, I got my new eyes? So this plus 511 gives me my new eyes. That looks like be 265.43. How do I get that? This plus that equals that. Now I got my eyes. Can I subtract the 3 green numbers and the 1 red? So if I take this, minus, 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 and minus. Okay, if I do that, I get the following. 260.77. 261.45. 264.23. And this particular problem, they said that TP2 had a recorded elevation of 263.64. No, 62. The recorded elevation here was 62 actually, 263.62. So we're only a 1/100th off. They had that recorded. We did our job and we came out with 1/100th over. So now, one last concept. We've got everything you need to know, I believe. I indicated that if I take the beginning elevation, I add up all the back sights, add it to it, subtract all the foresights, I should have the ending elevation. Okay, now hopefully you can see the value of that IFS column. If I mix those IFSs with this column, now I got to go in through and identify which is a foresight and which is an intermediate. By separating like that, I don't have to worry about it. So all I got to do is add these two numbers, 983 and 381. So if what I said before was true, I could do this. 257.61 plus minus So here's the beginning elevation. Here's the sum of the back sights. Here's the sum of the foresights. If I add the back sights, subtract the foresights, I should get the ending elevation. And look at what I got for the ending elevation. That means my math was done right and everything seems to mesh. Okay? So, challenges for you. Number one is putting the numbers into the table in the right spot. Crisscross. A back sight on, go to back sight, put your number where it belongs. All you got to do is be cognizant of what those spots are. If I want to know any spot, this spot right here, there's got to be a back sight on TP1. Okay? Number two is the progression. You don't go across. You go up, across, eyes down. Up, across, eyes down. up, across, down. Okay? If you can figure that out in your head, I like to I like to visualize a picture. Okay? Just take a visual picture of what's going on and then just follow it in your head. We do this a lot of different places. You know, even in residential construction when I was doing, we put a line on the wall and we measure up and down from that line, a level line. Because if you set your cabinets on a floor, the probability of them being level is about 0. So we have to use shims to keep everything level. And we do that with a line. Okay, the last thing, difference between a laser and a level. Okay, the concept is identical. The problem is you don't have your eyes to worry about. Okay? You will see these everywhere on the job sites. They're used universally. They're used by everybody that I know of. I've seen finished carpenters use them. I've seen concrete guys use them. I've seen guys that grade use them. Excavators use them. All these guys use them. Okay, a level. Tripod with a scope. You level it. You look through the scope. You read the rod. Okay? Concept. Difference between that and a laser. You have a tripod. You have a laser sending device attached to the top. That laser sending device spins around in a circle. And when it spins around in a circle, after you level it just like you do this. There's an infrared line that spins in the sky. Goes all the way around the circle. It's a red laser line. You can, I don't know if you've seen those pens that you can point on the wall. Just like that. Okay? We take and we have a rod. It's either a rod with numbers on it or it's a stick. A lot of guys use a stick. To that rod, we mount the target. The target mat, it's got little jaws on it. We mount it to the rod. All we do now then is we stand behind and slide that target up and down the rod until it makes a real screechy sound. It'll chirp for a little while. It'll go chip, 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 make a chirping sound. And then all of a sudden it'll level out and it'll be a solid sound. Or there's a little target designation on the back that kind of comes in and it turns solid when you're on it. All we do is take that, we move this target up until it hits exactly where this laser is. When it does, it makes an audible sound. We tie the target to the rod and we read the rod after we tie the target to it. So you can use it one of two ways. You can find elevations with it, or you can set elevations. For instance, I've got a site benchmark. I set up my laser. I find the elevation of my laser. So I'm going to do a typical thing we do all the time. There's your laser. You walk out in the field. You go to your site benchmark. You move the target up. You find out the height of your instrument. Notice there's only one person doing this. You don't have two people. That's the beauty of it. Okay? Now, I know the elevation of my formwork for my footers. I can take and figure out where to put that target on the rod. so that the bottom of the rod is exactly the elevation of my formwork. Now when I go to set the formwork, I can move the form up and down, and that target's going to move up and down, and at one point it's going to make that squealing noise. When it makes a squealing noise, I know I've got the top of my formwork exactly where I want it. So digging a hole, setting forms, setting sidewalks, setting curbs, we can do that all by ourselves. This laser, which has eyes that are an infrared ray, doesn't need another person. So a laser uses the same concept as the level, except instead of eyes, it's a beam of infrared light. We use it exactly the same way, used everywhere. One of your jobs may be to set the target on the rod so that the foundation elevation is right. And the guys in the field then will use that, and when it squeals, they know they've got it right. They set it, you pour it. What happens if you screw it up? You're out there with a jackhammer the next day beating the shit out of it, trying to get it out of there and save your reputation. So lasers and levels are very, very common instruments in our industry, used a lot. We'll be playing with them out in the field. We'll have to set up the notes, and we'll have to take data. You have to reduce the notes. You have to check and make sure you didn't screw up. What happens in the field with students is amazing. Number one is I've had students out on a flat piece of ground to the east of this building. I've had students off by 5-6 feet. There isn't 5-6 feet of difference in elevation in the whole city of Bowling Green. They're off. Now I've got blind men that can do it better than, I'll tell you what it is. It's a very common, they think it's so easy, they just screw off. They don't pay attention. And when you don't pay attention, it costs somebody money. So I'm going to be on you when we get in the field. You're going to have to pay attention. You have to put the numbers in the right hole, because you're not going to leave there unless you get us in a position where you've got numbers that match. And we're going to do a circuit, so your back sights and your foresights should add up to the same number. Okay, well that takes care of chapters 4, or let's see, the chapters number 7 and 8, which are the laser level and the level. If you want to do some homework problems, there are problems in the back of the chapters. Play with them. If you get screwed up and you can't figure out exactly how to do it, bring your questions to the lab.